Wi-Fi Sheep would like to say a huge thank you to all of you that kindly support us. Help us continue to bring new videos like this. Join patreon.com/Wi-Fi Sheep from just $1 a month. Hello, how you doing? And a very warm welcome back to youtube.com/Wi-Fi Sheep with me, Tom. Now, you will have to continue to excuse me slightly. I still have this cold, which has been lingering around for over 2 weeks now and is rather annoying. It's not COVID. I have done a test, but I just keep coughing now occasionally, so just have to excuse me there. Anyway, the reason for this video, which I wasn't intending of actually shooting this month, was I've had a bit of a development where two of my, if you like, favourite pet computer worlds have collided in a very spectacular and I think brilliant way. So if you are a regular to the channel, then you will know all about the Tiny Basic Computers and now Project Rio 8-bit build computer project. And those of you that have been with me for a couple of years may well remember the RISC OS Direct series that was also done here on the channel. Well, it turns out that for the very first time, RISC OS, that's the lightweight Raspberry Pi alternative operating system that you can run on the Pi amongst other platforms, originally from Acorn, can actually now talk to Arduino boards and a number of other microcontrollers outputting via USB serial. Never been able to do this before, but this is the first time, and I want to try a brand new driver that's been released called USB serial, of all things. And I want to try and install that and test this out and see if we can get one of the Project Rio Tiny Basic Computer Systems running on an Atmega, I think it's 2560 board. If we can get that to talk to a stock RISC OS. So that's the plan, and that's what we're doing today. Throughout this and many other projects here on Wi-Fi Sheep, I have been truly grateful to be partnering with PCBWay.com, the #1 solution for all your turnkey PCB manufacturing and assembly needs. And if you're like me and have an ever-growing interest and need in hobbyist electronics, then having a company like PCBWay at your disposal really is invaluable. If not done so already, do go and take a look at PCBWay.com and sign up for your free account. Trust me, once you get into having your own professional custom PCBs made, it really opens up so many possibilities for your own future projects. So don't delay, head over to PCBWay.com today. Okay, so the first place we need to head over to is riscosopen.org. Now, this is because I'm going to try and download the latest build of RISC OS, which is from RISC OS Open. And technically, it's the official build for the Raspberry Pi, which is the system we want to use. You can do this with RISC OS Direct, which those of you that are regular to the channel will know that I did a whole series on and was part of that project. As far as I'm aware, RISC OS Direct hasn't been updated as much as the stock Open version, so that's why for this build we're going to use the stock Open. So we go to downloads, and down here at the bottom we've got a number of distributions, and we're going to click on Raspberry Pi, and we have complete SD card images. This is what we want, so we're going to click to download. So got the image here. This is RISC OS Pi version 5.28, and it's a zip file that we need to unzip. Creates a folder, and in that folder we have an image and a readme. So we need to flash this .image to an SD card. I have an SD card here on the Mac. You can do the same process for PC, Linux. It's the same process. And I'm going to use Blina Etcher, which you used before. So we're going to say flash from file, and we'll go desktop. We'll just pick our IMG file. We choose the target device. Important to select the correct storage device, not the hard drive. And we'll click flash. So we want security validation for the Mac. So we'll just put that in. Okay. And we'll let that flash, and then it will do a checksum to make sure it's flashed correctly. And that should give us a SD card image. Bearing in mind, this SD card, once burnt, probably won't mount again on the PC or Mac. So if it wants to just eject, just let it eject the card, and that should be done from the PC or Mac side, and then we can switch over to a Raspberry Pi. Right, whilst that's flashing, we need to grab the USB serial drivers for RISC-OS, and these can be found at ftpc.iconbar.com/USB/index.html, and I'll put a link to that in the description of the video. And on this site, it's the first one here. It's serial.usb, which you want to click and download. It's not a big zip file. It's only 58.2K. Very important that you do not unzip this on your Mac, PC or Linux. It must stay closed as a zip file. Copy this zip onto a FAT or FAT32 formatted USB stick, because we're going to need to drag it onto RISC-OS. If you unzip the thing, it'll lose all its RISC-OS file formatting, which means it won't work when we try and install it on the actual system. Okay, for this demonstration, I'm going for the absolute worst case scenario, which, bring it onto camera, this is an original Raspberry Pi 2011-2012 version. So it's the single core ARM Broadcom chip. I think this is 512 megabytes of RAM, clocked to 700 megahertz. So these originals are actually slower than the Raspberry Pi Zeros, although it uses the same chip. The Raspberry Pi Zeros are all clocked to 1 gigahertz, 1000 megahertz. So this will run a little bit slower. It's the original. It's now, well, that's 2011, 2012. So we're what, 12 years old, 11, 12 years old, this board. So that's what we're going to use. Because it's original, we need to get a SD card adapter. It's got one here. So here's our mini SD card, and that will go full size there into the back. I'm going to plug in HDMI into the video capture card, so you can see what's happening on the screen. Because we've only got 2 USB ports, I'm going to need to use a hub, and in the hub I'm going to put a keyboard. I've got a cheap mouse. And also off camera, I've got a Raspberry Pi 3 power supply, which uses the mini USB standard, not the USB-C. The reason for using a 3 is it has a little bit more power, or amps I should say, which these early boards really do need, otherwise they sort of suffer from shutdowns and power offs very quickly, and it can get extremely annoying. Right, so that should be done. Let's power up. And the lights come on. Let's see what we can see on the main capture. There we go. So this is the newest build. At the moment, it's just trying to find network connection, which we haven't got one. So we can just hit escape and just hit cancel. And straight through desktop. So I'm just running on a 4:3 monitor, which is why you're seeing it as a 4:3 image. It does support widescreen. I'm just running it in 4:3 mode at the moment, so which is fine for what we need. Okay, so basic desktop as is. There's not an awful lot bundled on this. There's a few things, but not a huge amount of stuff. Which is kind of why we did direct originally, but it's fine for what we need, basically. Okay, so let's grab the USB stick. I'm just going to put that into the hub. So it comes up as an icon here, and let's just go and find the zip file, which is always fun when there's lots of junk on the system. Serial USB, there it is. So we need to copy that somewhere. So serial USB, we click, drag, and that will copy. So we can take the USB stick out. And we now need to unzip. So we double click it, we just open a file like that. What we need to do is create a new directory. So we middle click and we'll say new directory, and we'll call it serial USB. We open that, and then we can select all, click, drag, drop. There we go. And that's everything we need. So we can actually delete that if we want. Middle click, and we need to go to where is it? There we are. So middle click, directory, delete, that can go. Right, so basically in order to make the USB serial work, we just need to implement it, and we can do that by double clicking this module. It appeared that nothing has worked, but now the USB serial module for RISC-OS is now actually installed and working. So in theory, if I introduce a target device, so I have one here, this is one of the Mega, to show you down on camera, this is the Mega 2560 devices that we use for Tiny Basic computers, and now Project Rio, and these have never been compatible with RISC-OS, hopefully, until now. So, got a USB A to B type plug, so we'll just plug in. Now this board, by the way, has already got Project Rio Tiny Basic installed, and it outputs via USB serial and serial 0 TXRX it's a baud rate of 115200. Now that's important because that's what this serial is going to work at. So let's plug in directly to the Pi. And the board, see here, lights up. Now back to RISC-OS, and if I double click Serial Terminal, it'll open a task window, and you'll see that it's actually already read the CH340 USB 2 serial device. Nothing has appeared underneath, but keeping in this task window, if I now hit return, you'll see we've now got a basic cursor. And if I was to hit reset on the Arduino Nano, there we go, Project Rio. SD card error, of course, because we've not plugged the board directly into an SD card. It's just running as a blank empty board. But you can see there is version 4059, which is a new version that I will have for patrons backing Project Rio very shortly. And you can see it's loaded in with the amount of RAM available. We've actually got a program already in the EEPROM on this, so we can ask it to E-list, and there is the program. But I could also add a new program if I wanted. So this is one of the advantages of having a light OS like RISC-OS to act as a kind of secondary background operating system for Project Rio. So if I middle click down here, and let's just create a text file. So I've got this text window open here, and I just type in a very simple basic program. So I go 10A, let's see now, equals, so I'm equals symbol, equals, I don't know, 36, 20, question mark, which will be short for print, A, 30, end. Really, really simple program in basic, in Tiny Basic, or Rio Basic as it's going to be known. So we can select all, middle click, select, copy, come over to this window. Let's just type in new to make sure we've cleared everything. List. So yep, nothing in the system. Middle click. Down here, edit. Select. Paste. Hit the return or enter key. And list. Value is actually now on board the Arduino, on board the Rio Basic. And if I run, it gives us 36 because that's what we put into A, and we can ask it directly to print A, and 36 is in A. So basically what this means is that we could have an editor, a click and point editor that we can manipulate much easier on screen, and we can copy and paste programs in and out via the serial link, which RISC-OS is now capable of doing. Bearing in mind I've just done all this on an original Raspberry Pi, which is running really, really fast with RISC-OS. And this OS, unlike Linux, doesn't have a kernel that has to be booted and shut down properly. I can just pull the power out on this. In fact, let's just pull the power out. So let's just kill it right dead now. Turn the power off, dead. Okay, so no, didn't even do a proper shutdown, just killed it midstream, if you like. So still got the setup. Let's just power back up. There we go. If we didn't have the network running, it would boot instantly. So we'll just cancel that. Back in, no problem at all. And serial is still there. Just need to make sure we run the module. By the way, we can, if we wanted to automatically run this module, we could set it up into the boot directory. So I'll just show you where that is. You hit SD card, there's this thing called boot, which acts a bit like the system folder. If we shift double click, and we double click choices and boot, and you could actually drop it into tasks, or you could drop it into pre-desk. That's also fine, that'll work, no problem. So basically anything that you drop into boot will actually run. So we could just, let's drop it to tasks. Click, drag, drop. It's going to drop the module here, and that should, if I've got that right, should now implement without needing to be double click. So let's just shut down, restart the system. Okay, back up, boots almost instantly. So let's just see, without double clicking USB serial, if we're going to work. Yeah, because we're now running. So the USB serial module is now booted on load. So we don't have to double click that. And we've got serial terminal here. It's found our terminal again. And, oops, make sure we've got num lock off. Yeah, because I know, I realised what I've done there. Let's just go new. And system's back up and running, and eList. So what we could do, for example, is I could directly save to the SD card if I had one fitted to the Project Rio system, or I could actually write a program here on RISC OS in Tiny Basic, or download one, and I could copy and paste it straight in and save it to the onboard EEPROM, which is 4K of onboard EEPROM storage on a Arduino Mega. Yeah, so despite RISC OS's limitations, it does have a few major limitations. For this sort of thing, where we have a direct use case, it could actually be really, really useful. I said it boots up really quick. It's not Linux. It doesn't crash in the way Linux does when it's not turned off properly. It's quite robust in that case. This works really, really well. It's quite happy talking to the Project Rio board, and my basic interpreters running really nicely. And yeah, this could be used as a kind of secondary GUI interface operating system for Project Rio based computer systems, which is again one of the reasons why I wanted to implement a Raspberry Pi into the project. So it's not just a graphics terminal. We could flip this on its head and also run an operating system on here that then talks to this board as a secondary device. So if you want to follow what I've done, all the links will be in the description to the video, and you can have a play for yourself. This will work with the Tiny Basic 4 color builds or the new Project Rio build, which you can get for joining our Patreon at patreon.com/Wi-Fi Sheep. Tiny Basic 4 color build is available on the $3 downloads, general downloads tier, and we have the new $8 or £6 Project Rio tier, which will give you the new versions compatible with the Mega 2560. I'm going to continue to develop this a bit further because I honestly feel this could be used as a toolkit GUI interface for the Tiny Basic computer system, not instead of what we already have, but as a kind of switchable background OS that you can use for manipulating files via USB sticks and also doing copy and paste editing, something you won't be able to do very easily with the front end basic interpreter as we've had it running so far. So if you haven't done so already and are interested in all these projects, do like and subscribe to the channel. Thank you once again for your company, and I hope to see you real soon right here on the channel. Until next time, bye for now.